Okay, everybody, this section is section 12.2. It deals with arcs and chords, and so we got some stuff from chapter 10 that kind of comes back to us, and then we have chords, which we kind of learned in the last section, all right? So I'm going to put these definitions up. If you want to hit pause after I pull them all up, and you can write down definitions in your note packet, and so hit pause after I pull them all up. Okay. Okay. So let's use a circle off to the right to kind of illustrate some of these. The center of the circle is P. We learned dealing with trying to find the area of polygons. We had, the apothem and the perimeter. Everybody didn't like doing that, but they want APB to be my central angle at this point. So remember, a central angle here, though, is going to have its vertex at P, or the center of the circle. Okay, so we kind of learned that before. A minor arc has a measure that's less than 180 degrees. So usually when it's just two letters, that will usually tell you it's smaller than 180. So AB would be a minor arc, less than 180 degrees. And if you'll notice that this arc, AB, is going to be equal to this central angle. So the angle is actually creating the arc, and because it's drawn from the center, they're going to be equal. Okay. A major arc is going to be greater than 180, and so typically we're going to give you 3 letters to be able to identify, which way do you want me to go around the circle. This one's telling me to go from A to C to B. That arc is going to be bigger than 180 degrees, okay? A semicircle, in this case, a semicircle is really going to be kind of equal with 180 degrees. It's going to be equal with a diameter. You might want to write that down, okay? Semicircle is really created by a diameter. And if you remember that definition, it has to go through the center of the circle, okay? So here they want us to be able to identify, MN, what is it? Well, if the arc MN is created by the angle MRN, which is a central angle, and we learned that if a central angle creates an arc, then they're going to be equal. So MN should be 80 degrees, okay? MPN, okay, that's a major arc, so I know it's going to be bigger than 180, or I'm sorry, it's going to be bigger than 180, but because it's part of a circle, and I already know, this MPM takes all the rest of the circle except for this little arc MN, we already found that. So couldn't I take that small arc and subtract it from the big arc and get that measure? So if I did that, I hope that makes sense. If I did that, I should be able to get that, and that equals 300, or together they equal 360 degrees, but that one right there is going to be 280, okay? If I went from P to M to N, okay, that intersects the diameter here, and I know a diameter is cutting a circle in half, so half of a circle is going to be 180 degrees. So remember, a arc that's equal to or with the diameter is going to be half of it. That's 180. Okay. All right. So hopefully that was pretty easy. Those are test questions. Hopefully we can do well on that. The measure of an arc formed by 2 adjacent arcs is the sum of those arcs. So duh. We keep getting these all year long. An arc plus an arc equals a bigger arc, okay? You know, we did that with angles, we did it with line segments. If you add two together, you're just going to get a bigger one, okay? So for GE, GE goes from here to here. So remember, it's only two letters, so it's telling me, hey, it's got to be less than 180. In this case, it's that. Well, GE is really arc GH plus arc HE. Sorry for my writing. Dang it. I'll make this neater. Sorry. Not much neater, but hey. And that creates the arc GE. Okay. So that's going to be 40 plus 80 equals 120 degrees. Okay. So not rocket science there. Hopefully we get that. Not so bad. G, E, F. So three letters tell me it's probably going to be bigger than 180. And that's just really three different arcs all kind of put together. So 40 plus 80 plus 110 should give me a measure of 230 degrees. Okay. Okay, so then now they're telling me to go for CGF. Well, that's telling me to go this direction. It's only two letters. I go that direction. I could pretty much tell that's going to be less than, 180 degrees. Okay, well, I've really pretty much, back in this last question, got pretty much the whole circle except for this last arc that they're asking me to find. So shouldn't I be able to take the entire circle and subtract what I had before and get the measure of this last arc? So hopefully that makes sense. And I could do that. So GF is 130 degrees. Okay. So test question right there too. Hopefully not too difficult. Okay. So in this particular question, I'm kind of putting the question ahead of the rule. So let's just kind of do this the right way. Let's look at the rule down here. 12.8. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Okay, so a lot of words there, and I'm looking at the picture and I'm going, wait a minute, there's no diameter there. But I still could, I'll take this one as the example, I still could extend that through and get a diameter. And if the diameter bisects a chord, now this line right here is a chord, it's touching the circle at 2 points. If it's perpendicular to it, if the diameter is perpendicular to the chord and it bisects it, it's also going to bisect the arc that it's created. So there's an arc here that's created by this chord, okay? And it did all that. So I'm assuming, if I did that and they say it's 16, it bisects it, this is 18 and this is 18. Well, 18 plus 18 equals 36. So shouldn't X here also be 16? Okay, whatever, inches, centimeters, whatever, okay? So kind of illustrating that rule before we actually got to it, okay? In 12.9 down here, in a circle, if a diameter bisects a chord, and a chord's not a diameter, remember they're kind of the same, but a diameter is more specific, then it's perpendicular to the chord, okay? So that's kind of that same picture up above, just saying it in different ways. In theorem 10.12, in a circle, the perpendicular bisector of a chord contains the center. So that's kind of what that one's showing you up here in the picture that we had above. Let's go ahead and draw this one since we made a mess of that one. So here we got a circle, and let's just draw a chord, and it's being bisected by a line. So let's show that it gets bisected and it's perpendicular. Sorry, mine's not so great there. Hopefully yours is better. See if I could draw it a little bit better. bigger circle perhaps. Chord perpendicular to it, and it bisects it. It has to go or come from the center for that to work, okay? So I'll get rid of this mess down here, okay? So three theorems, all really kind of saying the same thing. Not really, converses, but they're all kind of saying the same thing, okay? And using that picture up above, all right? So coming down here in the circle O, AB is the diameter, so that means it's going through the center, okay? And it's perpendicular to the chord, so let's show it. What conclusions can you make? Well, first off, if I go back to my rules, it's perpendicular. They told me that. But it also bisects the chord. Well, the chord is CD. Okay? So if we go back to our rules, what happened to CD? Well, it got bisected. Well, what's bisect mean? It means it cuts it into equal halves. So really CD, I should be able to say that line segment CE is going to be congruent to line segment ED. Because that's what it says. That's what the rules just told me. And that's a conclusion I could make. It also talks a little bit about the arc too. If you go back to the very first one, it does something to the arc. So arc CD, which was created by the chord, that also gets bisected. So I could say that CB is going to be congruent to arc BD. Okay? So hopefully, those theorems are there for us to memorize and know. We're going to have to study those and make sure you do that. There's one last thing that we can conclude from that, kind of illustrate a little bit up there, but it wasn't really like mentioned. But with that, if I have this center point and I know it's in the center and I know that every radius is equal to every radius, then I should be able to draw a line from O to C and from O to D, and they should be equal too. So line segment OC is going to be congruent to line segment OD. Okay, so that really isn't mentioned, but I think that comes back up again. That's something that we're kind of hoping you can figure that one out on your own, but I think that shows up again, so you might want to make sure you notate that. Okay. All right, so that was section 12.2. I hope you got that. Just a lot of words and lots of vocab, lots of theorems you gotta know. So make sure you study this one pretty good. Okay.